Welcome back. Today we're going to do 17 letter combinations of a phone number. This is a really good problem to practice. It goes over, I'd say, a really good example of recursion, and I'd say this is a good interview question as well. Okay, given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. The mapping of digits to letters, like that, just like on the phone buttons, is given below. Note that 1 does not map to any letters. So 1 doesn't map to any letters. 0 also doesn't map to any letters. So what do we have here? Let's look at example 1, digits 2, 3. So what is 2? 2 is A, B, C, and 3 is D, E, F, right? So you could have any number, you could have any letter from here, A, B, or C, and that becomes, any of the first letter. Let's say first letter here, and then the second letter for any of these is D, E, F, right? So D, E, F is the options for here, right? So for each one of these, we can have um, one of these three options, right? And you can imagine, if there's a 1, let's say, 1 maps to nothing. So let's say there was a 1 in here, right? Um, Nothing would happen, right? It would just be blank, I guess, for each one of these. Um, and then if there was something like let's say an 8 or something, TUV, well, TUV would then be another branching factor, right? So you can imagine this tree where throughout this process you're picking up certain letters that become, let's say, like a path, right? So let's say these letters becomes one of the options, right? What is that? That is a C, a D, a blank, because the 1 is nothing, and a T, right? So this is the one of the letters here. And you can see all the letters, right? You can see that it's ADT and then AET, and then, each one of these paths becomes one of the strings. Now, you can imagine if we had a go function that we are going to call recursively, it can keep something like path, right? And we can append to it. So a go function probably needs something like, let's say, some letter that we're iterating over, or some number, right? A number represents many letters. And then for the letters of that number, right? For the letters in letter, we're going to recursively um, create a new path, right? So the new path would be something like the existing path plus the letter. And then we want to call, um, the recursive function with something like the next letter and a new path, right? And that's what we're returning. Um, we're not returning anything yet, right? So we have to think of through our base case. So in a lot of these recursive functions, if we did have a results array, right? At what point do we want to append into the results array? And that's as if path is, the correct length. Then we put into a results array, else we continue iteration. I hope that all makes sense. Um, I believe it'll make way more sense if I just code some of it. So let's think through what we're doing here, right? Let's have a go function, and it takes a letter, And it doesn't have to take the exact letter. It can take an index, and we can index to the letter, right? And then a current path. And we can imagine we call this the first index, and the path that's, let's say, it's an array of letters, empty array. We return results, and we are going to create some results, right? So results will be something like this, and we need to do something, right? So what do we need in this path, right? We need, for the letter in letters, we're going to have some idea of a new path, and then we're going to have some idea of a new index, right? Which is the next letter, right? So what is letters, right? You've got to get letters. Letters currently is nothing. So we currently need to map it um, from a number to a letter, right? And this part is quite boring, but you'd imagine um, index it by 2, and we have um, some of these letters here, A, B, C. I don't remember the letters. I'll make this smaller and bring it out. 3 is D, E, F, and etc., etc., right? So those are the letters, right? So for letter in letters, we're actually doing num to letter. And what is a num? Well, the num is digits at this index. That's the actual num. And then I'm iterating over the letters, right? So what is new path here? New path is exactly what we have in our drawing, the existing path plus the existing letter that we're currently iterating over. And what is new index? New index is, well, we can just iterate the index, right? So it would be index plus 1. So our base case could actually, depend on the index if we wanted it to, right? So if the index is the length of digits, then results append path. Now path, I think it should be a string, so we're going to have to join this path, right? So dot join the path, and then we return out of this function. So that's our base case. We're going to get the letters here, right? So we're going to iterate over letters, and we're going to create a new path, create a new index, and then actually do the recursion, right? So we're going to do go at this new index and at this new path. Now, we don't have all the letters, so maybe we'll fail some test cases, but this should prove out num to letter here. What do we have here? Key error 2. Well, we do have a 2 right there. Num to letter. What's wrong with that 2? Does the 2 have to be a string 2, like in JavaScript? Strange. Ah, I see. So 2 is a string because this digits here is a string, right? It says num, so it's a little confusing, but it's actually a num string, right? So, for clarity, I'm going to put num string here because that could be confusing if you're used to types, and num most likely indicates an int or a float in your own brain. Okay, so if the input is 2, 3, then the output is all of these, right? It's exactly this drawing. It's not exactly the drawing because I added the third, but it would be this drawing, right? Where this is AD, this is AE, AF, BD, BE, BF, CD, CE, and CF, right? And that's exactly what is being output here. AD, AE, AF, BD, BE, BF, CD, CE, and CF. All right. This is what we've created. We have a case here where an empty digits string should return an empty list. That that makes sense to me. We can actually just, do that in the very beginning. So if digits is an empty string, just return an empty array. And let's submit this and see if we got, okay, so we didn't fully complete it because we have, we haven't fully completed all the numbers. So let's just do that part. 5, 6, 7, 8, 9. Okay, so what we haven't handled actually, and I wonder if it's in the test case, is what would happen if there was a 1 in the middle of our number. Right, remember we have this third here, and the third here was a 1. And we wanted to do with the 1 is actually just continue on. Right? I haven't taken care of it here because I'm just wondering if it's in the test case. But you could imagine what we would do, right? Here we're iterating over the nums. What we would do instead is, because there's no letters to iterate over, if this num string was a 1 or a 0, we would continue the iteration without adding anything to the path, right? So let's run this, see if the test case covers. Okay, this should have been a 9. All right, so the tests actually don't cover it, but it should. What if there was a 1, right? So if the num string equals a 1, what we should be doing is calling go, right? And then index plus 1, and then the same path, right? We should continue this. And if it's not a 1, we'd want to do this, right? Or if the num string was equal to 0. So it's not in the test case, but this would be best practice, because there's nothing in here, does it? Oh, it says it's in the range of 2 to 9. Okay, well, you'd imagine as a bonus part of an interview question, if you wanted to make this harder, you have to handle the 1, right? So if you look at these test cases, it's a terrible test case, right? So here, if I added a 1, and I run it, okay, well that's silly. You'd imagine if I took this question and wanted to make it harder, I would just add the case where it could be a 1 or a 0, right? And then anybody who's practiced this question may get kind of thrown out of a loop because they didn't completely, memorize the right one. So sometimes when you're doing some of those problems, you think, how could I make this harder? Because if I was creating a question for an interview, I might take a very known question like this and just make it harder, right? I would just randomly make it harder. So one way to make it harder is require 1 and 0. But other than that, that's pretty much what you could do here. So what's the runtime of this? Well, for every one of these, there's up to 4 numbers, or four letters. And we're actually required to do that branching factor, right? So it's 4 to the power of n is the height of this tree, right? So here we have 3 letters. There's 4 to the power of 3. And that's how many we're going to have here. Roughly 4, right? Here it's 3 letters, so 3 to the power of 3. What is 3 to the power of 3? Well, it's 3 to the power of 2 here, so it's like 9. Let me delete this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's 9 here, right? So it's 3 to the power of 3, 3 to the power of 2, I mean. And yeah, that's that. Well, happy to do my third problem of the day. I will see you on the next one. If you wanted to optimize this, this is currently only beating 26%. So, you can think through some different way to optimize. I actually have this extra check, so it's going to be slower than even the vanilla version. This new path is creating a new array, so maybe there's a backtracking version of this that doesn't require it. Right. Like if the path, okay, you can stop watching at this point because I'm going to try something new, but you can imagine maybe the path is global to this function. We don't pass it in, or we can pass it in, it doesn't matter. Okay, let's just say we pass it in, and what's going on here is I'm going to append, so instead of creating a new path, I'm going to append to it. Right, so path dot append this letter. I'm going to do this, I'm going to pass in the path, and at the end of this, I'm going to remove the path. So after every go, you would expect that there is a removal. Let's see if this still works. Let's take this out. Don't need this anymore. Run this and submit this. All right, somehow slower, but much better on memory. Thanks a lot. I'll see you at the next one.